Hi, good morning and welcome to this video. And in this video I'm actually going to measure the copper and lead in tap water. So before we put the emphasis on lead, but now this system is actually quite good because actually it does copper and lead in parallel. So one sample, two results. So I will go ahead and just quickly start the science, if I can call it that. Well, I can call it that. What I'll do is I will take some tap water. I'll explain where I got this tap water from shortly. So I'm just going to take the tap water, and as I say, I will explain where I got that from. I'm also going to take just one volume of buffer. So this is basically just one volume of buffer with one volume of the sample. Because this is tap water and this is buffer, I mean, these are very miscible solvents, or not solvents, they're solutions. So I can just shake it up just really quickly like that. I'll put that down. I'm just going to put a clean sensor onto here. As I say, I'm going to, this is copper and lead. When we first went to market, we went just with lead, but now I'm going to put the emphasis that we're actually doing copper in parallel with that. And ironically, copper is actually a higher concentration in tap water. So this is a domestic tap water source. I'll just put the sample on, just give it a final shake. But as I say, this is two solutions that are easy to mix. They're both water based. So I will just get the 50 microliter pipette. I'll put that sample on there, and then I will give you the background story as well. But I just want to kind of get the science or the demo on. Right, so real tap water, just a 1-to-1 mixture with the buffer, 50 microliters onto the sensor. I'm not sure how long I've been speaking for, but you know, the samples prep is quite straightforward. I've got an app, it's in Bluetooth connection with my phone. I've given it a name so I can find this data later on, and I'll just go continue. I did a 1 in 2 dilution, so I just choose that and off it goes. So it takes about 4 minutes to prepare the sample, and then it does a very quick, when I say prepare the sample, it does 4 minutes of pre-analysis, and then it actually does the analysis. But I can see the progress in real time. I have a raw signal kind of streaming there, and I also get the timeline along there as well. So this is much quicker than otherwise getting a sample, bottling a sample, sending a sample off to a lab, waiting, you know, maybe 6 weeks to actually get the results back, by which time the results are actually not so useful because it's the real-time results that people are actually after. With that said, that will be running in the background, and I will go to here. So as I say, I'm doing copper and lead, but much more of an emphasis on copper. In fact, this is the tap that I took it from. This is an upstairs bathroom tap. Yeah, in fact, there we go. But actually, what it is, I also went round and took samples from several taps around the house. The reason being is I realized that this really helps, because when I say helps, it really helps with mapping the lead and copper in a situation. You know, you can go into a commercial or domestic situation, and you know, you can have the main source of water, which may be within, you know, regulatory limits, but then you can kind of wander around a building, maybe an older building with lead piping, and actually find out that in certain taps or water sources there's actually higher than you would otherwise be legally allowed copper or lead. So as I say, it really helps in these situations, because otherwise you're trying to kind of collect samples, document samples, send the samples to the lab, and then you have to kind of get the results back from the lab, and then you have to kind of map results onto sample location, and that can actually be quite, you know, logistically, errors can happen in that kind of situation, especially if there's a time delay of, like, you know, possibly 6 weeks to do that kind of turnaround. But with this, we can go around, quickly collect the samples, do the testing, and say, okay, well, that was upstairs bathroom, and this is the result, kind of thing. So it's much easier to do that. So I did actually go around my house finding, you know, the lead was gladly quite low, but the copper was actually the one that was a little bit higher, and I did find that in several. But when I say higher, the legal limit I think in the UK is 2 ppm, 2 parts per million, which is 2000 ppb. So I found that the copper in some of my taps was hovering around the 1 ppm or the 1000 ppb level. So, but it was in within sort of, let's say, legal limits. But I do have copper, and I'm not, why should I be surprised? We have copper piping. What I was looking for was lead, but within legal requirements. Actually, I didn't have a problem, let's say, with lead. But the copper signals were actually quite distinct, but within legal limits. When I say that we're waiting for the result is actually going to come through in a minute, but we're basically kind of enriching the copper, and then we're actually detecting the copper. So that's why there's a kind of pre-step. I just want to change cameras for a second because it's coming to the end now. It's on its last 30 seconds. So it does a pre-step where it's essentially enriching the sample, and then we do a next step where we actually measure how much heavy metal, in particular lead and copper, is actually in that sample. So we kind of got a 10 seconds. But what's nice is you kind of get a real sense that the instrument is working, because we get this kind of confirmation. And here it goes, waiting, and now it's doing the next part, the analysis. So here it goes. The analysis itself is quite quick. There we are. There's a little something there. You can see it. That's probably the copper actually. So let it. It's going to do its analysis now. So while it's just doing that, I'll just go back to here and just say that we're essentially we're looking for copper ions that are in solution. So we enrich them on our sensing surface, and then we strip them away, and in stripping them away from our sensing surface, we can then measure how much copper is actually in the sample. So I've got my result. This is really consistent, by the way. I keep getting this, well, as you would expect. What I want to do is I just want to share my screen with you for a second. So my lead is low, which is good. So I'm within my sort of legal requirements on lead. I'm also within my legal requirement on copper. I'm at 1100 ppb, which is 1.1 ppm. And I'm quite happy with that. 2 ppm is the limit, but when I say quite happy with that, I wouldn't necessarily drink the water from that particular tap. It's an upstairs bathroom tap, so you can appreciate it's been through all the house system. That's why they say, sort of drink from the tap that's probably closest to the mains water, because then you've had less sort of chance of picking up copper in the household system. But I'm within legal requirements, but I'm 1.1 ppm, where the legal limit is 2 ppm. So for some of you, you could actually argue maybe I should really be filtering that water. So the technology is based on sound scientific principles. As you saw the top floor results. The top floor results for me are within legal requirements, but I probably recommended to actually run my water in those taps. And I'm not going to drink from the taps anyway, because you always drink from the tap that's closest to the main source. But if you do that in your own house, your own facility, you may get some interesting results. If you do have any questions regarding the detection of copper, in fact, what I will do for a second is actually just show you this. That I should have said that it said upload complete, and upload complete means something that, especially if you're an inspector in some ways, you kind of want the evidence of this. So here's my copper and lead. All my data has automatically gone to the cloud, so I'm not only get a result there and then on my phone. Somebody who's maybe remote from me can actually see, what time I got the results. See, that time can be a really important part of the signal, because this is 8 a.m. in the morning. So you can actually appreciate that the taps have not necessarily been run that much. This is the date, so time and date is already taken care of. The location, because I gave it, I called that the location out there. Who did the work? That's really sometimes important. And then I've got my lead result, which is 0.77 ppb. So that's, I think the limitations, depending where you are in the world, can be 4 or 5 ppb. So I'm okay on my lead. And then on my copper, I get a much bigger signal. And my copper is we rounded up on the app to 1,100, but 1,097 or 1,098 ppb, but we rounded up on the app just for kind of ease. But you can also then, if you so wish, download this as well. So if you need to sort of save this as evidence for somewhere, you can export that as a PDF as well. So then you've kind of got that as a record. So in summary, in this video, I described how I collected a sample, I prepared the sample, I ran the sample, and I discussed whether I was in or outside of legal requirements. And you also saw that I was able to do lead as well, but the lead was very low, and the copper was also within legal requirements, but was actually a lot higher. And that generally is the fact that you get a lot more copper in drinking water, at least where we've been surveying, than you do lead. If you have any questions, don't hesitate to reach out to us. I'll put a link underneath the video. Okay, thanks very much.